Now we'll demonstrate to you what is DC interference. We have a foreign pipeline which is coming in the ROW of GAIL. This foreign pipeline is coming close to the GAIL's anode bed at one location and crossing the GAIL's pipeline at another location. The point where the pipeline is closer to the GAIL's anode bed, current pickup will take place and the potential values will be more negative. The point where the current will discharge, the potential values will be more positive. Now the current will discharge at the crossing location as the resistance is least at this location. Let us see what happens with the potential values. Let's see what happens at the pickup location. When the TR unit is on, the PSP value that you get is minus 0.71 volt. When the TR unit goes off mode, the value comes to be minus 0.599 volt, that is the native potential of the foreign pipeline. Let's see what happens at the discharge location. At the discharge location, the on PSP value is minus 0.320 volt and the instant of PSP value is minus 0.58 volt. At the instant of PSP value indicates that the potential is getting back to its native potential. At the pickup location, when the GAIL TR unit was on, we were getting a value of minus 0.71 volt. When the GAIL TR unit was off, we were getting value of minus 0.60 volt. Now the change in potential, that is TR unit on value minus TRU off value, shows us a negative value which indicates that the current is being picked up. So the location that we had shown you for current pickup location, which was nearer to the anode bed, shows that at this location current is getting picked up. Let's see what happens at the discharge location, that is the crossing location. When the GAIL's TR unit is on, we are getting a value of minus 0.34 volt. When the TR unit is switched off, we are getting a value of minus 0.59 volt. Change in potential value shows a positive potential swing of 0.169 volt, which is greater than 100 millivolt, confirming to DC interference. Now, in order to complete the circuit, the current that is discharging from the foreign pipeline will get picked up by the GAIL pipeline and will take the return path to the TR unit. This is how DC interference takes place.
This is a case study involving two pipelines, Pipeline A and Pipeline B. As you can see in the diagram, Pipeline A is crossing Pipeline B. The black multimeter is measuring the potential of Pipeline A and the yellow multimeter is measuring the potential of Pipeline B. When the TR unit of Pipeline A is interrupted, we get the following readings on Pipeline B. The on potential of Pipeline B is minus 1.4 volts and the instant off potential of Pipeline B is minus 1.6 volts. On the contrary, the on potential at Pipeline A is minus 1.46 volts and the instant off potential of Pipeline A is minus 1.25 volts. The shift in the potential of Pipeline B is on potential minus the instant off potential, which is equivalent to positive 0.20 volts. There is a shift of potential which is greater than 50 millivolts on the Pipeline B due to the interruption of Pipeline A's TR unit. This is a clear indication of DC stray current interference. Therefore, DC stray current interference on Pipeline B can be observed.